Okay, just a minute. The screen is visible to you now?
Yes, yes.
Okay, so can you tell me that what would happen if we kept the bleaching powder in open air? Have you revised the topic that we have done in the previous class?
Yeah.
So then tell me what would happen if bleaching powder is kept in open air?
Bleaching powder.
Yes. Sorry, yeah, bleaching powder is kept in open air.
Open. Then like chlorine is there, so
Yeah, chlorine, that it will, what will happen? Bleaching powder is CaOCl2. Okay.
yeah,
Then it will react with the atmospheric carbon dioxide and will form CaCO3, and plus chlorine gas will be eliminated out. Okay. So the
yeah.
strongest smell of chlorine, the chlorine will be eliminated out. Okay. Okay. So we have done this one, and the last topic that we need to do is can you tell me the last topic that we need to study today? Uses
Last
of bleaching
topic.
powder, na? Uses of bleaching powder, na?
Yeah.
So what are the uses of bleaching powder? That the important thing that bleaching powder is used as disinfectant, means it is used for killing germs. Okay. So it is used as a strong disinfectant, means it is used for killing germs. It is chiefly used for bleaching, means bleaching cotton, textile, okay, wood, pulp, etc. If we can say that if it is employed, or we can say that it is employed for making the wool unshrinkable. Unshrinkable means if the wool is like this, so it is used to make it unshrinkable. Got it?
Yeah.
Got it? And it is used as a strong oxidizing agent in many chemical. It is used as a strong oxidizing agent. Okay. Why
Okay.
it is used? Because it is used to remove the electron, because it can easily remove the electron from one. It is brings about the, or sorry, it can add the electron to the one. So bring about the reduction. So it is actually used as a strong oxidizing agent. So keep in mind that it is used as strong oxidizing agent. Understood?
Yeah.
Understood this one? Okay.
Yes.
So should I move forward today? So will you be able to please note it? Please take the screenshot of this one. The very, very important. This is bleaching powder, means it is used as strong disinfectant for killing germs of water. Okay. This is the most importantly and many times being asked a question. Okay.
Yeah, I've
Please note
taken
it.
shot.
Taken. Okay. So next is the next salts. This question we have done in the previous class. Okay. Now the next question, next salt is actually washing soda. Okay, washing soda is prepared by, washing soda is actually, we can say that it is prepared by solvay process. Okay, and it is actually sodium carbonate decahydrate. It is actually sodium carbonate decahydrate. What is washing soda? Washing soda is NaHCO3 dot 10H2O, sodium carbonate, sodium carbonate, sodium hydrogen, sodium carbonate, Na2CO3 dot 10H2O. It is sodium carbonate decahydrate. Okay. And how it is prepared? It is prepared with the help of Solvay process. Okay. Will you keep in mind? Will you remember? It is
Yeah,
prepared by
solid.
Solvay process. And how it is prepared by Solvay process? Let me explain you. Let's, you can check it here that how it is prepared by Solvay process. Okay, what are the raw material? First of all, what are the raw material being required? Okay, raw material. The raw material that is being required for the washing soda is NaCl, ammonia gas, and calcium carbonate. Okay, so what is going to happen? Let me explain you. Okay, what we are just going to take here, NaCl plus water plus NaCl plus, sorry, water is not taken as raw material because most of the time water is easily available, so we don't take it as a raw material. So NaCl, okay. So how it is prepared, let me tell you. First of all, we will take NaCl and H2O. This make it a concentrated solution of this one, and this is called brine. What we called it? We called
Brine.
it brine. Okay. And okay, after this one, we pass ammonia gas to it, and this become ammonical brine. What we called it? When ammonia brine, when added to NH3, ammonia gas is passed through it, it become ammonical brine. Ammonical brine. Okay. So first of all,
Yeah.
the raw material is this one. First of all, the raw material is this one. The second raw material is this one. Okay,
Okay.
this one is the first raw material and this one is the second raw material. Got it? So next is we pass carbon dioxide to it. So when ammonical brine is passed with carbon dioxide, okay, then it gives you sodium hydrogen carbonate plus ammonium chloride, NH4Cl. Got it? It will give you sodium hydrogen carbonate, and this is the baking soda. So if we are going to have the baking soda also in our salts. So this is the same thing. Baking soda. By baking soda, we can prepare washing soda, or we can say that the first step when we are just preparing the washing soda, first we need to prepare the baking soda. Okay, got it? Got it? Here you need to note it down that we are just passing the carbon dioxide to it, but our raw material is not carbon dioxide. Our raw material is CaCO3. Okay, it's CaCO3 because we didn't buy the carbon dioxide gas. We actually heat this CaCO3 to 900 degrees Celsius temperature, and then it will get converted into CO plus CO2. This CO2 that is being eliminated is being passed through this ammonical brine. So let me show you here that what we'll take first of all water, NaCl, and ammonia. This is called ammonical brine. Okay, in a tank. Okay, and this ammonical brine is filtered here. This is the filter you can see. This is filter when we make some concentrated solution, salt, water, and ammonia gas. This is called ammonical brine. Then we filter it and we pass it to the carbonation tower. And what is carbonation tower is going to have? You can see that we are just heating calcium carbonate to it. In this tower, we are just hitting the calcium carbonate. So when we start hitting the calcium carbonate, okay, when we start hitting the calcium carbonate, then carbon dioxide, okay, then this carbon dioxide that is being produced here is passed through this carbonation tower. Got it? Is passed through, which is going to have filtered ammonical brine. Got it? Carbonation tower. Okay, then we're going to have the PPT of sodium hydrogen carbonate. This will form a PPT. Sodium hydrogen carbonate, PPT will be formed. Okay, sodium hydrogen carbonate, or we can say the baking soda. Yeah, we will filter it. Okay, the filtrate will remain here. Means sodium hydrogen carbonate filtrate will remain here, and another ammonium chloride will pass through it. Okay, so actually, what we are just going to take the raw material. If the question comes in MCQ that what are the raw material for solvent process or for making baking soda or washing soda, the raw material is NaCl
and NH3.
NH3 and calcium carbonate, not carbon dioxide. Okay, if water is there in the option, then you can take the water option also. Okay, means if the fourth is also given, then you can take the water also. Okay, if it is not given water, then it's okay because water is easily available. Got it? Understood?
Okay. Yes.
So what is going to happen here is that first of all, we take the ammonical brine. Okay, and after taking the ammonical brine, we pass the carbon dioxide to it. Okay, we pass the carbon dioxide to it. You understood? So carbon dioxide gas, when ammonical brine, this brine, when added to ammonia, this become ammonical brine. When it is added with carbon dioxide, then it will give you sodium hydrogen carbonate plus ammonium chloride. Okay. This ammonium, sodium hydrogen carbonate, please note it down first here. Don't draw this one. Okay. Write down this equation. Write down this one, even in your copy. First note it down. Okay. Note it down.
I don't need to draw, right?
No, you need not to draw. We're not going to draw this one, okay? Just write the equation. Solve the process, done?
Yeah.
Okay, ammonium chloride. So this is forming the white PPT. Okay, when this white PPT is formed, we filter this one. We filter this one. It is going to have when the mixture is being prepared. Okay, so here the sodium hydrogen carbonate will settle down. This is baking soda. This will sodium hydrogen carbonate will settle down, and another will remain in the aqueous, mean in the soluble form. So another thing will remain in the soluble form here. It will remain as it is. Okay, got it? It will
Yes.
remain as it is. So what we are going to do here is that we will filter this sodium hydrogen carbonate, and after filtering this sodium hydrogen carbonate, what we are going to do here is NaHCO3 when heated. This is baking soda also. Okay, you need to keep in mind when baking soda is heated, then it will gives you sodium carbonate plus carbon dioxide plus water. Keep in mind that carbon dioxide can also be produced when you heat baking soda. Got it?
Okay. Yeah.
Got it? Understood?
Yeah. Yeah. Understood.
Now this is Na2CO3. Now this Na2CO3, when it is added with 10 water molecules, okay, then it will gives you finally Na2CO3 dot 10H2. This is called washing soda. This is called washing soda. Washing soda. This is sodium carbonate, but it is not going to have 10 water molecule or 10 water of crystalline. So this is considered as anhydrous sodium
Hydrogen.
sodium
Sodium.
carbonate. Sodium carbonate. Okay. So this is considered
Okay.
to be as anhydrous sodium carbonate. So please note this one here. Just a minute. Note this one here. That when this NaHCO3 is heated, it will gives you Na2CO3 solid anhydrous form, and this plus carbon dioxide plus water. And when this sodium carbonate is given 10 water molecule. So what you need to do is, Faris, you need to practice by writing the equation at least three times. Okay, then it will be going to give you the confidence. Okay, don't don't learn it without practicing, without writing. Okay, just writing. When you learn something and you write it one or two times, then it will gives you the confidence that you know this question and you can do this one. Got it?
Yeah.
Note this one.
Yeah. Wait.
Note up to here.
Okay.
So how we prepare the washing soda? First, we take the aqueous solution of sodium chloride and water. That is called brine. Then we pass ammonia gas to it. Okay. Then it
Yeah.
become ammonical brine, and then ammonical brine is added with carbon dioxide. Then it will gives you the PPT of sodium hydrogen carbonate, which is baking soda. When baking soda is heated, then it will give you sodium carbonate plus carbon dioxide and water. And when this sodium carbonate is added with 10 water molecules, then it will gives you sodium carbonate decahydrate, okay, which is washing soda. Done?
I'll do
Noted?
one second. 1 second.
Done?
1 second.
Okay, okay.
Alright, done. Yeah, done.
So next is uh, so how it is prepared. So write a note on preparation of washing soda. So note it down. The washing soda can be prepared by passing carbon dioxide to ammonical brine. Okay, and this is the reactions. Write it down fast. Not this page. This is very, write it fast. Or take the screenshot of this one. Just take the screenshot of this one that you have to copy this one in the homework. Okay.
Okay.
Will you maintain,
Okay.
do you promise me that you will do this one?
Yeah.
Will,
Okay.
because I can check it. Okay.
Okay.
So you need to make this one.
Yeah. Done.
Okay.
I've
Next.
taken screenshot.
Okay. So again, let me explain you one more time that what happens, how bleaching, sorry, washing soda is prepared. So washing soda is prepared when we take the NaCl plus water. This is brine, and we pass ammonia gas to it, then carbon dioxide. Then it will gives you sodium hydrogen carbonate. Okay, got it?
Yeah. Yes.
Okay, and then plus carbon dioxide plus water. So not carbon dioxide plus ammonium chloride. Okay, ammonium chloride. Now this is solid PPT. This is PPT. This will settle down. Now this sodium hydrogen carbonate when heated, this will gives you Na2CO3 plus CO2 plus water. Here CO2 and water is formed. I will ask you this question. This is very important. We're going to discuss what is the role of tartaric acid. Okay, then we're going to study the baking soda. So this is very important. Okay,
Okay.
got it.
Got it.
Next is when this sodium carbonate Na2CO3 plus water, 10 water molecule, then it will gives you NaHCO, sorry, then it will gives you Na2CO3 plus 10H2O, then it will gives you Na2CO3 dot 10H2O. This is known as water of crystalline. This dot water molecule is known as water of crystalline. Okay,
Okay.
water of
Crystalline.
crystalline. Okay, will you keep in mind this one?
Okay. Yeah.
Okay.
Yeah.
Okay. Okay. Next is baking soda. Baking soda. Okay. Baking soda is known as sodium hydrogen carbonate, and this is the same how we prepare. It is prepared by solvent process that we have studied. That ammonical brine when passed with carbon dioxide. From where we get this carbon dioxide? Can you tell me? Where we get this carbon dioxide?
Oh, what? Which one?
From where we get this carbon dioxide?
Uh, we get the carbon dioxide from heating the calcium carbonate.
Yeah, we get this carbon dioxide when we heat the calcium
Calcium.
carbonate. Okay. Okay. Next is, now note it down. That what is the use of this baking soda? Baking soda is sodium hydrogen carbonate. It's commercial use. What is the use of this one? That it is being used. Okay. What is the use of baking soda actually? Baking soda is used in for baking purpose. Okay. And in commercial use, when we are using baking soda, sodium hydrogen carbonate. Okay. So it is added with some edible acid. We call it tartaric acid. Tartaric
Acid.
tartaric acid. We call it tartaric acid. Okay, this is an edible acid. This is an edible acid. Okay. So when this baking soda is added with tartaric acid, it become baking powder. Baking
Powder.
powder. This is tartaric acid is edible acid. Edible acid. So if the question being asked that what is the difference between baking soda and baking powder, so what you will answer?
Uh, Baking soda and baking powder.
Yes. What is the difference between baking soda
Baking
and baking
powder,
powder?
NaCl3 is added with an edible acid.
Yes. So when baking soda is mixed with some edible acid, it become baking powder. So the question comes that why we are just mixing this edible? Why we are mixing this edible acids? Okay. Why we are mixing this edible acids? Why we are adding tartaric acid to the baking soda? Okay, so question comes that why or what is the role of tartaric acid or edible acid? What is the role of tartaric role of tartaric acid? Is my screen visible?
Yeah.
I don't know how I stuck this one. Okay, just a minute. Just a minute. Is it visible to you
Yes.
now?
Yes.
So what is the role of tartaric acid? Tartaric acid actually. When metal hydrogen carbonate react with acids, okay, when metal hydrogen carbonate react with acid, it will gives you salt plus carbon dioxide plus water. What it will gives you? It will gives you salt plus carbon dioxide plus water. Okay, so this is metal hydrogen carbonate when it is added with acid. Acid is tartaric acid. So acid contain H plus ions. Every acid, so we just write it acid. We are just not going to write the formula of tartaric acid. So it will gives you salt plus carbon dioxide plus water. And this carbon dioxide, we require this carbon dioxide in order to make the bread fluffy. Actually, when we add baking soda uh, or baking powder to a dough, okay, like this is a dough, okay, to a dough, then uh, when acid and when acid, tartaric acid and sodium hydrogen carbonate, which is baking soda, mixed together, the reaction will start and it will start producing carbon dioxide. It will start producing carbon dioxide. Okay, you understood? It will start
Yeah.
producing
Carbon
carbon
dioxide.
dioxide, and this carbon dioxide trapped in this dough. Okay, so
Yeah.
how this carbon dioxide is being produced? This carbon dioxide is produced when sodium hydrogen carbonate is treated with acids. Okay, which is edible acids. So actually this tartaric acid is helping. This tartaric acid is helping, okay, in which
Yeah.
in the elimination of carbon dioxide. Okay, and
Hmm.
this carbon dioxide get trapped, which when we heat it, when we put it in the oven, then this carbon dioxide will escape out from here. Yes. Is I'm audible to you,
Yeah.
Faris?
Yeah. Yeah.
Faris. Okay.
Hello.
Now, what is going to happen? This NaCO3 when react with acid, what it will give you?
Any?
Tell me. It will gives you. It will give you salt plus carbon dioxide plus water, and this carbon dioxide will help in eliminating out in making the bread fluffy. So, what is the first role of baking soda? What is the first role of of edible acids? That it help in the production of carbon dioxide, which is used for making the bread fluffy. With this carbon dioxide is being used for making the bread fluffy.
Yeah.
Okay. Okay.
Okay. Yeah.
The second thing here is the second thing that is happening here is that this sodium hydrogen carbonate is actually this sodium hydrogen carbonate is a basic salt. Basic salt. How I can say that it is basic salt? Because when strong base NaOH react with weak acid in it, this carbonic acid, this is strong base and this is weak acid. Weak acid. When it react, it will gives you what?
Um. Which
It
one?
will give you sodium hydrogen carbonate.
Yeah.
Okay.
Sodium
And
hydrogen
plus, so this is
carbonate.
the
Two.
parent is for this salt, the parent acid is parent base is NaOH and acid is H2CO3. This is weak
Yes. Yeah.
acid. So when this NaCO3 is a base, sorry, it is a salt of strong base and weak acid. So it is a basic salt. It is a basic salt.
Basic.
Okay, basic salt. And its taste will be bitter because base have bitter taste. Got it?
Yeah.
Got it?
Yeah.
So
Yeah.
when this sodium hydrogen carbonate is treated with some acid, so actually this is basic in nature because it has bitter taste. Okay, it is a salt, but it is a basic salt. So base when added with acid, it will gives you salt plus water. Means this salt will neutralize. Means this salt will neutralize the bitter taste. This acid will neutralize the bitter taste of this one. Okay, because this base is treated with acid. So acid plus base will give you salt plus water, which is neutralizing. So the bitter taste of this baking soda is neutralized by tell me.
The bitter taste of the baking soda is neutralized by the tartaric. I
Tartaric
mean, by
acid.
the.
By the tartaric acid. Okay, because it is a basic salt. Because it is a basic salt. Understood?
Yeah.
Understood? So
Yes.
what is happening here is that this sodium hydrogen carbonate, when react with acid or tartaric acid, the salt so form this time plus carbon dioxide plus water. So this salt will not have much bitter taste because this is treated with acid. Only if this is present in the dough, then neither the carbon dioxide will be produced nor or and it will further give you the bitter taste. So when tartaric acid is added, so carbon dioxide is released and moreover it neutralizes the bitter taste because baking soda is basic salt. Okay, you understood?
Yeah. Okay.
Understood? Understood?
Yes. Yeah.
So please note it down. Make this one. Baking soda is prepared by solvay process. Both washing soda and baking soda is prepared by solvay process. Okay, and note it down that how it is prepared. This is baking soda here, and commercial use is when baking soda is treated with edible acid, it will gives you baking powder. And what is the role of baking powder? That baking powder, when edible acid is added to the baking soda, then will give you salt plus carbon dioxide and okay, it
Mm.
neutralizes the bitter taste and moreover. So note it down, please.
Yeah. I can't see the screen. Hello. Hello.
Noted?
Yeah.
Faris, noted? Okay. So what is the role in simple language? If I ask you that what is the role of baking soda? Sorry, tartaric acid in the baking powder. So note it down.
Reduce.
Note it down. Note it down here
Yeah.
that it help in the production of carbon dioxide, which help in making the bread fluffy in baking industries. Second role is it neutralize the bitter taste of baking soda. Okay, this is NaCO3 as it is a basic salt. Okay, and you need to keep in mind that you have to learn this one by just practicing. Okay, when you learn it and then you write it. Okay, in your copy. Noted, Faris?
One. Wait. I started to write now. Yeah, noted.
Now, what are the uses of baking soda? What are the uses of baking soda? The first use of baking soda is that it is being used in soda fire extinguisher. Where it is used? In soda acid fire extinguisher. Okay. First use was in the baking industries. Okay. Second use is in soda acid fire extinguishers. What is soda acid fire extinguisher is going to have? That this soda acid fire extinguisher actually have, okay, this is the here it is going to have the sodium hydrogen carbonate. Okay, and here it has the bottle of acid. Okay, which is H2SO4 sulfuric acid. Okay, and here is the needle or a pipe. Okay, needle here. Okay, that comes to here, and there is a pipe here. Okay, that comes. So this is named as soda acid fire extinguisher. Extinguisher. Okay, soda acid fire extinguisher. What happens in soda acid fire extinguisher? When you press it, okay, when you press it, then what is going to happen here is, okay, this glass bottle which is going to have H2SO4 will break and will react with sodium hydrogen carbonate. So sodium hydrogen carbonate, which is a metal hydrogen carbonate, when react with acid, okay, when react with acid, which is H2SO4, then it will gives you what? Na2SO4 plus, tell me,
H2.
plus
H2.
H2O plus CO2. This is the general
Yeah.
equation when metal hydrogen
Carbon.
carbonate react with, tell me,
H2. H2SO4.
Acid. Yes, metal hydrogen carbonate or metal carbonate, both. Okay, if it is metal carbonate or metal hydrogen carbonate, like sodium carbonate, Na2CO3, if it is going to react, or if it is NaSCO3, sodium hydrogen carbonate, both if they react. Okay, if metal carbonate or metal hydrogen carbonate, metal carbonate or metal hydrogen carbonate, any of them is going to react with acid, they will give you salt plus water plus carbon dioxide. And this carbon dioxide is used to extinguish fire. Why? Because the molecular mass of carbon dioxide is 44U. Got it? And
Yeah.
that of oxygen is 32U. So since it is heavier than oxygen, so it comes, okay, it will remove the oxygen from the fire and will form a layer of carbon dioxide which will extinguish the fire. Okay, got it?
Okay.
So it
Yeah.
is used in soda acid fire extinguisher. So note it down, this one, note it down, only this one, up to here. So it is used in soda acid extinguisher because it is here the carbon dioxide is being released. Okay. Noted?
One. One
Tell me
second.
fast. Noted?
One second.
Noted fast. Last
Yeah. Done.
salt is plaster. Last salt is plaster of Paris. Okay, plaster of Paris. First of all, a question comes in your examination that for making a baking powder, for making cake, baking powder is taken. If at home your mother uses baking soda instead of baking powder, then how will it affect the taste of the cake? Tell me, and why? Instead of baking powder, she took baking soda. You know the difference of baking soda and baking powder?
Yeah.
Then what would happen?
If baking soda is used. Um,
What is
First
baking
of
soda? Baking soda is only sodium hydrogen carbonate, and baking
yeah,
powder is NaSCO3 plus
yeah.
a double acid. Okay, yeah, tartaric acid.
There is no there's no enough. There's no acid
No, no,
in
no, a double acid is mixed with it. Then what would happen? What would happen? Tell me.
since tartaric acid is not there. There would be
Yeah,
no carbon dioxide.
yeah, no carbon dioxide will be produced. And other,
Yeah.
no carbon
Uh,
dioxide means the cake will not become fluffy
yeah, it won't be fluffy.
and it will add the bitter taste. Okay,
Okay, yeah,
because tartaric acid is used to to neutralize the bitter taste of the baking soda.
yeah.
Okay, so how can you convert baking soda into baking powder?
What?
How will you convert? Tell me.
I didn't hear you. What did
Yeah,
you
by
say?
adding. I'm
No, no.
asking that
What
how
did?
will you convert? How will you convert baking soda to baking powder?
Baking
By
soda to
adding.
bake.
By yeah. By adding. By adding a small amount of edible acid like tartaric acid to
Yeah.
it. Okay.
Yeah. Yes.
Okay. So this is baking soda, and when they mix together, they become baking powder. Got it? And what is the role of tartaric acid added to baking soda? So we have done that it help in elimination of carbon dioxide, which help in making the bread fluffy. And secondly,
Yeah.
it neutralize the baking bitter taste of, tell me,
Bitter
bitter
taste.
taste of baking soda or
Soda.
powder? Baking
Oh,
soda.
soda.
Okay. Don't get confused with soda and powder. Okay. Got it. Next is plaster of Paris. Plaster of Paris is actually POP, which is calcium sulfate hemihydrate. Okay. So CaSO4 dot half H2O. This is POP, plaster of Paris. Got it? What we called it?
Yeah.
We called it plaster of Paris. So plaster of Paris is CaS. So how it is prepared? When we take the hard mass substance, which we called it gypsum. Okay.
Yeah.
When we heat it at a fixed, means controlled heating should be done. Controlled heating should be done. So when controlled heating is done, then which is the temperature should be 100 degrees Celsius or 373 Kelvin.
Kelvin.
Okay. Then what is going to happen? Then it will get converted into CaSO4 dot half H2O, and 3 by 2 water molecule will be eliminated out. You understood?
Yeah.
Okay. Next is when we have this is called plaster of Paris. What we called it, this is POP, plaster of Paris. Understood?
Yeah. Yeah.
This is plaster of Paris. So the question does not come that how, most of the time the question may become that how it is prepared. And most of the time the question comes that what would happen when plaster of Paris is kept in open air. Kept in open air. So if it is kept in open air, then what would happen? It will react with CaSO4 dot half H2O when it is kept in open air. Open air. So it will absorb the 3 by 2 water molecule from the atmosphere and will become again gypsum. CaSO4 dot half H2O. Sorry, 2H2O. This is called gypsum, which is hard mass substance. Okay. You understood?
Yeah.
So second question comes that what would happen when uncontrolled heating is done during the preparation of plaster of Paris? Uncontrolled means you are not just maintaining the temperature at 100 degrees Celsius. It is just means you keep on heating it. Then what would happen? Then this CaSO4 dot half H2O, when you keep on heating, then the whole of the water molecule of gypsum will eliminated. Uncontrolled heating. Uncontrolled heating is done. Then whole water CaSO4. Okay. Then 2H2O. So this will become without anhydrous calcium sulfate. We called it anhydrous, means without water. Anhydrous means without water. Hydrous means water. Okay.
Yeah.
Anhydrous calcium sulfate, which is also called dead bond plaster. Dead bond plaster. Okay. You understood?
Yeah. Okay. Yeah.
So how it is prepared? When gypsum is heated. POP is prepared when gypsum is heated at, okay, at 273. Actually, it is begin 100 degrees Celsius written in NCRT. So if we convert it into Kelvin, it is 373 Kelvin. But actually, the temperature is 120 degrees Celsius. Okay. Actual
Yeah.
temperature is 120, but we just follow the NCRT, so we have to use this one. Okay. Got it? So
Yeah.
if there is no option of 373, and if you need to keep it, if the option is 293, 93 is given, then you have to take this one. Okay. The first preference will be given to this temperature. The second preference will be given to this temperature. Got it?
Yeah. Okay.
Now, note it down this one. Okay. Plaster of Paris, don't write this one. Write this one, how
Don't.
it is prepared.
Water of crystalline, I don't need to write.
Yeah. Done.
Yeah, done.
Okay. The question comes. Let me write it here. What happens when uncontrolled heating is done during the preparation of POP? Note it down.
What? Uh,
What happens
was
when
it?
uncontrolled heating is done during the formation of POP? You have to complete your copy, okay? Otherwise, it will means you need to maintain the notes, okay? So if uncontrolled heating is done during the formation of POP, we have given you the notes. Have you received the chemistry notes in PDF?
I don't know. I have to check.
Okay. So note it down. During uncontrolled heating, this gypsum, the whole water of crystalline will be eliminated out and will become anhydrous calcium sulfate, which is known as dead bond plaster. Okay. So whole water of crystalline, this 2H2O is called water of crystalline. Okay. If any salt is written like this, like ZnSO4 dot 7H2O. So this 7H2O is the water of crystalline. Okay. Na2CO3 dot 10H2O. So if this 10H2O is water of crystalline. Okay.
Okay.
Done.
Yeah, done.
Okay. So take the screenshot of this one, that it is used for making decorative items. It is used for joining the fractured bone. It is used for making toys. Okay. The uses of plaster of Paris. It is used for making craft, patterns, molds, and statues. It is used for making fireproof materials, fireproofing. It is used for filling small gaps on the walls and roofs. Okay. So this is POP. Okay.
Okay.
Noted.
Yeah. Yeah.
Sorry, have taken the screenshot. Okay.
Yes. Yes.
So here the question comes in examination. Let's you do this discussion. This question is being asked if you have taken the class. Okay. Then you have done this question. Okay. Earlier. This question is being asked in your uh this pre-boards that I have checked it. Okay.
Okay.
This question is in your pre-board. So read the question first that we're going to answer. Read the question first.
Metal carbon.
Here is this question.
Yeah,
on
yeah,
your
okay.
screen.
I read it.
You read it. So what it's saying, a metal carbonate X. Metal carbonate means that this is metal and this is with
Yeah.
carbonate. Okay, got it?
Yeah.
A metal carbonate X, that letter is X and it is carbonate group. If we don't know the valency of this one, we are just considering this one metal carbonate X. Okay, on reacting with
Yeah.
acid gives a gas which gives a gas. Okay, so what happens when metal carbonate react with acids? Tell me.
Metal carbonate when it reacts with acid. Um, calcium. I think it's calcium carbonate in this case.
Yeah, we don't know right now. First of all, tell me what happens when metal carbonate react with acid. So it will gives you salt.
Plus water. Plus
Metal
carbon.
carbonate when react with acids, it will
Salt
gives
plus
you
CO2
salt
plus
plus water plus
plus
CO2.
yeah.
So which of the following is gas here?
CO2.
CO2 is the gas. Okay. Now moving to the next part here is, now this is CO2 is the gas. So he's saying that which when passed, this gas when passed through a solution Y. So this is a solution Y and this gas is being passed, I mean this carbon dioxide is passed. So it is saying that this gives the carbonate back, means you will receive this carbonate, metal carbonate back. So again you get XCO3. Got it?
Yeah.
Got it?
Yeah.
On the other hand, this is another case. On the other hand, a gas G which is obtained on the electrolysis of brine. What is brine?
In this aqueous solution of sodium chloride.
Yes, NaCl when react with water and when you pass the electricity, then what would happen?
Uh,
What is that process named as?
it is called electrolysis.
This chloralkali process.
Chloroalkali.
What would happen? NaOH plus Cl2 plus H2 will be formed.
Yeah.
Okay. So which gas is produced at anode out of this in this?
CO2.
Which gas is, yeah. Okay. Which gas is produced? Tell me, RS.
Chlorine
Which gas is
gas.
produced? Hmm?
Chlorine.
Chlorine gas.
Chlor.
Chlorine gas will produce because it is negatively charged, and negatively charged produce will goes toward the positively charged anode. Okay. So we'll say
Yeah.
that chlorine gas is going to produce. So this is at anode. At anode. So here it is saying that on the other hand, a gas G. So this is a gas G that is produced. That is produced on electrolysis of brine.
And,
Okay,
and
at anode. So if you have not learned, you can check it, that if you have not learned the all the preparation reaction properly, then you will not be able to solve this question.
yeah.
Okay, so at anode during the electrolysis of brine, okay, anode, uh, when passed to dry Y, I mean this gas G, on the other hand, a gas G which is obtained in anode during the electrolysis of brine is passed to dry Y. So this is Y. Okay, now it is dry Y. So Y, if it is dry or something, the formula will be same. So when this Y is added with this chlorine gas, it will gives you a compound Z, which is used as disinfectant. Disinfectant. So which compound is used for disinfecting the or
Bleaching,
killing germs in water?
bleaching powder.
So this is bleaching powder. This is Z is bleaching
Yeah,
powder.
what's
Okay.
like?
So this is bleaching powder. Z is bleaching powder.
Yeah.
CaOCl2. So tell me that we know the preparation reaction of bleaching powder. So to which compound we pass the chlorine gas during the preparation of this bleaching powder?
NaOH.
Which gas? Not NaOH.
Oh, sorry. Oh, uh,
Which gas? To which compound we pass chlorine gas in order to obtain bleaching powder?
uh, calcium carbonate.
Not calcium carbonate.
Oh, wait. It is H2SO. No.
It is
Mm,
calcium hydroxide. You have to remember this one, okay? It is calcium hydroxide. Got
Okay.
it? It is calcium
Calcium
hydroxide.
hydroxide.
Got it? So when this calcium hydroxide react with this chlorine gas, that will gives you bleaching powder plus water. Okay. So Y is calcium hydroxide. So this is also Y.
Yeah.
So when calcium hydroxide is treated with this carbon dioxide, what would happen? When calcium hydroxide is passed with carbon dioxide, then it will gives you calcium carbonate plus
2O plus CO2.
water.
Sorry, plus H2 only.
So this is metal hydrogen carbonate. Got it?
Yeah.
So here we have, so this is the XCO3. So X is calcium. Okay. So what is X? A metal carbonate X. No, metal carbonate whole is X. So metal carbonate is CaCO3.
Yeah.
Y is calcium hydroxide. Gas G is chlorine gas. And Z is, tell me Z. Z is bleaching powder, CaOCl2.
CO2.
So if you have not memorized the preparation reaction of this bleaching powder, the electrolytic reactions or the electrolysis of brine, or we can say the preparation of NaOH, if you have not prepared, if you have not remembered that what happened when calcium carbonate, calcium hydroxide or slag lime, we called it lime water. Calcium hydroxide is also called lime water. So lime water, when treated with carbon dioxide, it becomes milky. This is a very famous reaction. That lime water, when passed